Welcome to our channel. Today we're diving into the fascinating world of illusions, tricks of perception that make us question our eyes. From shifting lines to disappearing objects, illusions reveal how our brains interpret the world. Get ready to have your mind blown as we uncover the science behind 10 common illusions, exploring the psychology and neurology that make these visual puzzles so compelling. Take a look at these two lines, each capped with arrows. One points in, the other points out. Which line appears longer? It's a trick question, of course. The lines are the same length. Our brains, however, have evolved to interpret lines with inward-pointing arrows as corners closer to us, and lines with outward-pointing arrows as corners further away. This depth cue, ingrained in our visual processing, overrides our ability to accurately judge the line's lengths. This isn't a scene from Alice in Wonderland, though it might as well be. The Ames room, a trapezoidal room viewed through a peephole, creates the illusion of shrinking and growing people. The secret lies in the room's distorted shape and the viewer's fixed perspective. The sloping floor and angled walls create the illusion of a rectangular room from a specific point. This tricks our depth perception, making people appear to shrink or grow as they move across the room. Ever notice how a full moon looks bigger on the horizon than when it's high in the sky? That's an illusion. The Ebbinghaus illusion plays on size too. Two identical circles, one surrounded by larger circles, the other by smaller circles. Which looks bigger? The one with smaller circles appears larger even though they're the same size. Our brain judges size by surroundings. Imagine two identical lines on a converging railroad track. Which line appears longer? The one higher up, appearing further away along those converging tracks. This is the Ponzo illusion, messing with our depth perception. Our brains see the higher line as farther away. We perceive the higher line as longer, though it's the same length. Ever feel like the walls are closing in? Well, in this illusion, they kind of are, visually speaking at least. The cafe wall illusion features rows of black and white squares separated by thin gray lines. Notice anything strange? The lines appear to tilt, creating a wavy effect even though they're perfectly straight. This illusion stems from the way our brain processes contrasting colors and edges, leading to a misinterpretation of the line's orientation. Prepare to have your perception of parallel lines challenged. The Zollner illusion presents a series of parallel lines crossed by short diagonal lines. Do the long lines appear parallel, or do they seem to slant? They look slanted, right? That's the illusion at work. The short diagonal lines disrupt our brain's ability to process the orientation of the long lines, making them appear non-parallel, even though they are. This illusion is all about the power of suggestion. You'll see three black circles with segments removed arranged in a triangular formation, but here's the catch. There's no actual triangle there. Our brains, however, are hardwired to see patterns and complete shapes. Even though the triangle is absent, our visual system fills in the missing information, creating a perception of a bright white triangle superimposed on the scene. The Poggendorf illusion, misaligned but actually aligned. Two line segments separated by two parallel vertical bars. Simple, right? But here's the question. If you were to extend those line segments, would they meet? It doesn't look like it, but they would. The Poggendorf illusion distorts our perception of alignment. The presence of the vertical bars throws our brains off, making the line segments appear misaligned when they are, in fact, perfectly aligned. The hearing illusion, bending lines with a starburst. Get ready for some more line-bending fun. In the hearing illusion, two perfectly straight and parallel lines run through a starburst pattern. But do those lines look straight to you? They probably appear slightly bowed outwards, right? This illusion is thought to be caused by the radiating lines of the starburst, which interfere with our brain's ability to process the straight lines accurately. Chapter 10. The motion after effect, making still images move. Ever stare at a waterfall and then look at the stationary rocks beside it? The rocks appear to move upwards. That's the motion after effect, or waterfall illusion. Our brains adapt to the waterfall's motion. When we look at a stationary object, we perceive upward motion. Your mind on illusions. Thanks for watching. Enjoyed the mind-bending world of illusions? Like, share and subscribe for more. These visual puzzles reveal how our brains process information. Let us know which illusion blew your mind. Keep questioning and exploring the wonders of the universe.